Hello students, let's try to understand Gibbs energy changed and equilibrium. Right, this is what we are going to understand. We have seen how knowledge of the sign and magnitude of the free energy changed of the chemical reaction. Prediction of spontaneity of the chemical reaction, prediction of the useful work that could be extracted from it. So far we have considered free energy changed in reversible reaction. Let us now examine the free energy changed in irreversible reaction. A change in the reversible reaction. Okay, reversible under strict thermodynamic sense is a special way of carrying out a process such that system is at all time in perfect equilibrium with its surrounding, which apply to the chemical reaction. The term reversible indicates that a given reaction can proceed in either direction simultaneously so that a dynamic equilibrium is set up. This means that the reaction in both direction proceed with the decrease in free energy, which seems impossible. It is possible only if at equilibrium the free energy of the system is minimum. If it is not, the system would spontaneously change to configuration of the lowered free energy. So the criteria for equilibrium A plus B reversible C plus D. So in this condition, that is Gibbs free energy is going to be 0. So Gibbs energy for reaction in which all reactants and products are in standard state. So delta G naught is related to the equilibrium constant of the reaction as follow. So 0 is equal to delta G naught RT ln K. So delta RG naught is equal to minus RT ln K. It is delta G naught is equal to minus 2.303 RT log K. We know that delta G is equal to delta RH naught minus T delta RS equal to minus RT ln K. For strongly endothermic reaction, the value of delta RH may be larger and positive. In such case, value of K will be much smaller than 1 and the reaction is unlikely to form much product. In case of exothermic reaction, delta RH is larger and negative, and delta Rg naught is likely to be larger and negative too. In such cases, K will be much larger than 1. We may expect a strongly exothermic reaction to have larger K and hence can go near completion. Delta Rg naught also depends upon the delta S. If the change in the entropy of the reaction is also taken into account, the value of K or extent of chemical reaction will also be affected. So here you can see, student, what the conclusion. Depending upon the whether delta RS is positive or negative, using equation 6 point, it is possible to obtain estimate of delta G naught for the measurement of delta H and delta S, and then calculate K at the temperature for the economic yield of product. If K is measured directly in the laboratory, value of delta G at any other temperature can be calculated using the equation. So this is what the value of the Gibbs free energy, student. I hope you might understood.